Welcome to MOTG project videos. On this video, I will show you how to use the MOTG RS-232 to your project. RS-232 is a standard communication port for various industries and networking equipment. It is used to communicate two devices in a longer distance. However, most of microcontrollers do not facilitate direct RS-232 communication as they do not support RS-232 voltage levels. The MOTG RS-232, designed by 4D Systems, is a low-power, high-speed, low-cost solution for incorporating RS-232 serial communication to your design. It features the ST3232 CDR IC by ST Microelectronics. It supports both 3.3 and 5V power supply, up to 400 kbps baud rate, plus or minus 25V input levels, supports a 2-wire 3.3 or 5V TTL interfaces. The dimensions are 28mm by 37.15mm. On this project, we will be using two 4D Systems Gen 4 ULCD displays as our devices to communicate with each other in a longer distance. Device 1 has a knob and track bars that controls the angular meter and LED digit and gauges on the device 2, which will control the RGB Led and Servo motor. You will need the following: 2 units of MOTG RS-232, 2 units of MOTG breadtooth interface boards, 1 unit of Gen 4 ULCD 32D CLB as your device 1, and 1 unit of Gen 4 ULCD 35DT as your device 2, 3 pieces of breadboards, 1 unit of Gen 4 PA, 2 pieces of micro SD cards, 1 servo motor, 1 RGB LED 5mm, 3 330 ohm resistors, 2 power supply 5V, 2 FFC cables, jumper wires, 1 female to female serial cable, and 2 units of DB9 connectors male. Please visit our website for the complete code for this project. Open the code with Workshop 4. On device 1, line 100, ID is equal to 0 when track bar 1 is touched for color red. Line 101, value is equal to R pos N when track bar 1 is touched. Line 116, ID is equal to 1 when track bar 2 is touched for green. Line 117, value is equal to the G position N when track bar 2 is touched. Line 132, ID is equal to 2 when the track bar 3 is touched for blue. Line 133, value is equal to B pos N when track bar 3 is touched. Line 152, ID is equal to 3 when knob is touched for blue. Line 153, value is equal to pos it when knob is touched. Line 157, compute checksum, which can be used for error checking. Line 158, send qualifier at to the serial. Line 159, send ID to the serial. Line 160, send value to the serial. Line 161, send checksum to the serial. On device 2, we will be using COM1 of our display. Line 23, we set the GPIO2 as our receiver. Line 24, we set GPIO3 as our transmitter. At line 25, we set the baud rate of COM1 as 115,200 bytes per second. At line 81, we initialize the buffer, which can handle up to 20 bytes of data, and wait for the qualifier at symbol to begin reading. In line 88, if the buffer receives the at symbol, then it will sync. At line 89, if the buffer is greater than 2, it will begin reading the data. In line 99, if the ID is meter, it will initialize and change the value of the PWM pin which is connected to our servo motor. At line 101, else it will initialize and change the value of other PWM pin which is connected to the RGB color of the LED. At line 104, reinitialize the buffer. After completing the code, we are ready to build the project. You can now use the Mochi RS-232 to your projects. We hope you enjoyed this video. Thanks for watching.